Okay, Assalamualaikum and salam sejahtera. So for SKE 3742 Power Electronics Lab design sheet for basic AC to DC converter, also known as rectifier. So for this project, it is vital to know that for our daily activities, sometimes the load doesn't match the available supply. Okay, for instance, if we need to, for example, to produce a variable DC supply to drive, for example, to drive a DC motor or maybe battery charger for your handphone. Okay, but the only source available, for example, has come from TNB, and we know that from TNB or IPP, the available source is AC. Okay, so we need a rectifier, we need a converter to convert from AC to DC, okay, to do the job, right? Beside that, for certain application required control of power flow from source to the output, and sometimes the selection of power converter topology itself determines the size of the power flow control. Okay, so for this problem, or for this project, you are required to carry out a brief literature review, okay, and then you need to design and implement the energy conversion, sometimes known as power converter, okay, so that a variable DC output voltage with continuous load currents can be produced at the output, because we know that the output currents, it is possible to have discontinuous or continuous current mode. But in this case, in this project, we will focus more on continuous current mode. So the design converter must be able to supply variable voltage, okay, variable voltage to the passive load such as resistance and inductance. Okay, so we will focus on this load, okay, resistance and inductance only for this project. Okay, because that is the suitable load for undergraduate level lah. So we identify that for capacitor load, we will not focus on capacitor load for undergraduate level. Okay, so to do the job, okay, only one thyristor is permitted, only one thyristor can be used, okay, to construct the power modulator or to construct the converter. Okay, so you need to prepare a technical report, okay, supported with a set of data, and we will supply to you the experimental results due to this COVID-19. Okay, so it is expected that your data, simulation data, is in match with experimental data. And then, of course, you need to do data analysis, plots waveform, and present your waveform, verbally, okay, and present in the report as well. Okay, so we can call that as a log report. So this is the question that need to be answered. Okay, since this is your first lab, okay, so we will focus more on the basic, okay, basic of a converter circuit. So we start with half-wave rectifier. So the first question that you need to answer, so you can get it from textbook or you can get it from internet, but be careful if you want to use internet, because internet you need to filter there are so many sources from internet, so you need to filter whether it is right or wrong. So I suggest that you just use the textbook material, okay, so that it will not be hanging around find the correct answer for it, because this is university level, okay, we're talking about university level, so not general level. So the first question is what is the rectifier circuit, and then followed by the source, what type of source is needed, and then what is the circuit topologies available, followed by the application of rectifier circuits, and then how to vary the output voltage, and then relationship with the control angle and the generator output voltage. And next is how to improve the load power if we use RLE load. And final one is how to ensure the continuous current mode. Okay, thank you very much.